Hello everybody, my name is Welcome.
In this tutorial, we're gonna mod Heaven Benchmark into HDR using RENODX. First of all, download the benchmark, then clone RENODX. I'm not even gonna use the cmake stuff up here. Just go to the contributing file. Download the dependencies if you haven't already. Now run the setup commands up to the git submodules. I like to move out the games folder so that we don't waste time compiling everything. But then make another one in its place. This is so that we can copy the generic project over. Now let's actually build it out. So we need to copy this from contributing, do 32-bit like the game. The add-on should have been built into the build32 release folder. Now we need ReShade, the add-on version. Target heaven.exe, get Lilium's HDR shaders for the graph. You can load in, scope it out. The Luminance graph on the right really confirms everything. Look at these. There's no roll-off at all. It's a brick wall. Now we can move the add-ons over, but look at this. Pick link source, then drop as a symbolic link. Highly recommended, you should get this right here. The link is like this fake file that redirects it over to the real file. No more needing to copy and paste every build. Moment of truth.
Oh, HDR10? What? Hello?
Let's go to advanced mode. Let's try this. Oh! Try doing SC RGB. Let's see if it works. Let's try it again. Oh! What the hell, dude? Stop! We might have to do display proxy. Oh! I think it's working. Yes! So yeah, for this game, you need the proxy. It's like another layered on SwapChain. It's also DX11, so it's like on top of DX11. I don't know, it's just, you know, it just works. Let's make the proxy the default. So head to the add-on file code. Find the code for the SwapChain device proxy slider. Comment out everything. But let's take the important part out here and then turn on the proxy and turn off set color space. While we're at it, scroll up a bit, make sRGB the default because the proxy can just be weird. Finally, go all the way to the top. The SwapChain is kind of janky for this game, so disable the debug else you get spam. Also, add this line right here to toggle the new code for the SwapChain upgrades. Alright, pressing space stops the camera. Look at the cloud still moving. And this is where we pull out the Devkit. We use the Devkit to take a snapshot. This tells you everything that's being drawn in a frame. So like if I disable stuff, like you can start seeing, oh. Alright, this is the amazing rendering pipeline representation. Look at this, wow. When we take the snapshot, we can see everything that happens. We can see all the shaders that's being called. There's vertex, which is where to draw. There's pixel, which is you have where to draw. Now for each pixel, draw something. And then you have compute, specifically divide up the GPU and then do whatever math. We don't concern too much about vertex. It's off in the settings, but let's turn it on. So yeah, the vertex sets up the pixel, always. You can see the identifier hash code for each shader too. Luckily, Heaven doesn't use compute shaders, which are harder to decompile. When you click on the shader and scroll down a bit, you can see what the shader is instructing the GPU to do. Unfortunately, it's all just like move this, add this, and so the hardest part of HDR modding might be just deciphering these guys. So you got the shaders, but what goes through them? So there's constant buffers, always as input, basically a read-only list for parameters. And then there's textures, either an input or an output. They can be multi-dimensional, so like a container or canvas. Buffers and textures gets binded to the shader so that it can be used. Okay, let me just turn off this. Let's say like the first one, let's see. Detail fresh now, so these are the constant buffers. Look like they customize how the material is rendered. We can go to the exact draw call, draw index 0, the first draw call. Got the shader right here with the 2 constant buffer listed, and you got 4 input textures. The shader also says it too, 4 right here. And you have samplers. You use the samplers to sample the texture with like nearest filtering or like bilinear filtering or whatever. You also have the 3 outputs, the render target views, which holds the render target, which is basically the texture. It also says it on here too. Usually the Devkit can just render the texture, but I don't know, it's not working here. Right, quick, another thing to note is like, oh yeah, what are these formats, right? Here's the basics about texture formats. Most important is that some are unorm 0 to 1, we need floating point, which is past 1 in order to hold HDR values. And then you can also see, like, you click on one, the other one highlights because there's a history. It gets used over and over again, and then you can see like, oh, it went from being drawn to being an input. That means this shader is resolving everything accumulated. Hopefully that sheds some light on like the Devkit and how it's used. And thankfully, HDR modding usually only needs to change shaders from post-processing onwards, which are simpler. This is because all the complex rendering will spit out a raw HDR color. It is then in the post-processing that effects will clamp down to the SDR expected output. Disgusting. That's why we're gonna mod the FX to HDR, carrying it to the end. So the questions now are, where's the SDR clamping at? You know, what shaders and effect is causing it, and what output textures need to be upgraded to hold the new HDR values?
Well, you know, this is drawn to scale, so perhaps we should start working our way backwards.
Let's take a clean one. Okay, and then this looks like UI. Okay, then wait, the color froze. This is an important full screen effect. Let's see what this shader is. Alright, I don't know these, but they're unused. Motion blur, but also unused. And maybe depth of field right here. Bunch of samplers. This is multi-sampling. The shader must have the main color if this is here. And then this is a LUT 3D probably. 14. Can we find 14? It's probably near the end. 14. A LUT sampling, because this right here is padding. Here's a trick you can use. You can copy this and put into Desmos, take the reciprocal. Maybe we try this. What is this? 64. Whoa. And then this right here is log exponential. This is a POW. Like the log and exponential is how the GPU sees it, and it's basically like power but only for positive. And you can see like they're on the same line. And this right here is 2.2. This right here is Gamma 2.2 encode. Here's a quick rundown of Gamma. It goes all the way back to analog signals. Now it's just for perceptual reasons. Anyways, it's just a power function. This is encode to raise up the color and decode to lower the color. Here's sRGB. It's nearly the same, but it's piecewise. And compared to the 2.2 we saw earlier, this is slightly weaker. Here's both encoding. In the shadows area, sRGB doesn't raise the color up as much. And here's decode. sRGB doesn't lower as much. Gamma tangent over, the shader is most likely the main post-processing shader. So let's decompile it. Now head back to the contributing page. We need the CMD decompiler. Drag it in and open a CMD there. This guy dash, I think D like that. Or maybe small d, I don't remember.
Let's see.
Disassembling. Oh, then it's big D. Oh, right there. We should make a new folder in our project called shaders. Move it in real quick. It's now slightly more readable. Now we can find this and this. Alright, that's that. This is Gamma.
Encode 2.2.
And then this is LUT sampling. And then this is, I don't know. And then this is output. Here, let me do this. So now we can try to load it up. Right, let's copy the path. Go back here, go to the Devkit, go to settings, live path, paste it in. Now you can just load the shader. Alright, that works. Let's see. What if we, if this is Gamma encode, what if we return right here? This debug output. Let's see, guys. Oh! Alright, now why did that just work? First of all, it's the clamping. It was caused by the LUT. Out of all the other post-processing effects, this one takes the cake. Essentially, LUTs are like cached color grading. Cached as a texture, you can take your current color and use it as coordinates to sample the texture. That's why it's 3D here. The RGB channels are the coordinates. And like other textures, coordinates goes from 0 to 1. So when you feed it HDR color higher than 1, GG. Secondly, why did we output Gamma encoded color? Go back to the diagram. The linear color goes up right to where we had that Gamma, right? And it's Gamma encoded, which the UI is also in Gamma space because it's SDR. And then there's a proxy shader right before presenting. here. Look at that. And it's doing SwapChainPass. Look, it's decoding color, which is gamma in our case. And then it's gonna encode for sRGB or PQ. This usually doesn't happen, but yeah. But you know, rather we abide by the UI or we have to change every single one into linear. Yeah, no thanks. Like, flick this. This is actually linear color. And wait, what just happened? It just got clamped again. Is this not the same shader? Let's see. Oh, it's another variant. Bruh. To save performance, devs can have their shader completely disable an effect. If you have this, the GPU must still compute the branch. But if you have this, you effectively have two. That's what's happening here. Just like the other shader, decompile it and let it output the gamma encoded. And that's both of the shaders you need, at least for the current anti-aliasing mode. So now, right, we can answer these questions easy. Yeah, the HDR color gets held all the way into that LUT. We also didn't even need to upgrade any textures. Let's take a look at the LUT shader again. I did this upgrade right here, it doesn't even matter. Only at the swap chain does it get clamped, but that's already upgraded. But you know, this is a tutorial, so let's just upgrade LUT for the fun of it. Alright, we're back into add-on, it's near the bottom. And then resource upgrades, yep. Comment it out, and then let's take out the useful part because we don't need the automation, we just do it ourselves. So yeah, we're going 8 to 16-bit just for the accuracy. Don't ignore the size. We want 3D 32. Upgrading the view depends on the game. It's working here, so don't need to change. Finally, specify the usage as a shader resource. It's an input. Alright, now before we continue adding like HDR tone mapping and stuff, let's figure out like everything else. Alright, let's stop this previous output. That's good. Let's finally sample this guy and encoded gamma so we see what it does. And what is this? Freaking a checkerboard pattern. And we do this to Desmos 1 divided by that. This is 8-bit dither, and we want to get that whack out of here. Alright, let's try to see everything else. This is probably depth or something. And then let's see what this guy is. Oh, this is like lens flare. Let's see, what is this one? Oh, this is color. Looks like there's a depth of field right here. Something, what is this? Oh, whoa, this is like the depth of field texture. So we're blending it down here.
Color or depth of field.
I think this one was the multi-sampling one, so I think it's just gonna be multi-sampling data. Yeah. What is this guy? Oh, lens dirt.
Lens dirt text.
This is getting it twice. Okay. Oh, there it is. This is a
lens flare, like mirrored. I don't know what you call it. Mirrored sampling. This is even more, dude. How many did it have? There's so many lens flare.
By the way, these will be easy user settings. And then also one more thing to do is to just organize this in a new file. Common.hlsl. From right here to right here is basically gone. And we can do, okay, let's call it T for tone map, resolve LUT and gamma.
Float 3. X color.
What else do we need? We need a sampler, the texture, and a sampler. And that'd be nice to get the UV or the text chord. What do you call it?
The texture is sampler, sample state. Alright. And then instead of doing all of this,
so where's color? We want to pass in the same text coordinates for color. The shader will include common, and common will include shared. And when we include shared, we get access to the RENODX namespace or the helpers. Let's just put gamma encode 2.2 right now. Oh yeah, and also the other variant. Copy over include and the function. And there we go, now it's matching. And almost forgot, you should append a name in front of the shader file. And finally, the difference between the two is that one of them has a transparency composition for stuff like smoke. And like finally, Heaven has an OpenGL mode, and the Devkit can just dump the source code. This won't be pastable because it's OpenGL. When developing, I actually like to remove the final peak clamp. Go all the way into SwapChainPass or the draw.hlsl file, line 547 and 548. With this gone, we can check if we're overshooting peak. And one more thing, go back to the add-on file, uncomment all custom shaders. Building will now recursively find all hashcode specified HLSL files and compile them for the add-on. It will also guarantee our own constant buffer binding. It's defaulted to the last index in hopes that it doesn't bind over others. If you go to share.h, shader inject data contains all the values uploaded. Peak brightness, tone map type, post-processing. We'll make changes to this later. For now, let's just build out. Now, we can go about fixing brightness scaling. Game is not working, and then the UI scales it up and down like what is happening. Well, everything is pretty much automated, so just call RenderIntermediatePass. Here's what it does. Like all other functions in draw.hlsl besides SwapChainPass, it needs to take in linear color. This is the example to make UI darker. So it scales game color up and automatically encodes gamma for us. Then the UI renders like normal, which finally goes to SwapChainPass to decode gamma, invert this scaling, making UI now dark, and prepare the output for us. So back here, we just have to gamma decode prior to using it. But look at this, you probably saw a decode and encode safe by the autofill. We need it here. Remember, POW doesn't work with negative numbers. So safe is just saving the sign and reapplying it later. It's mirroring the function, but why even bother with this? Firstly, both RenderIntermediate and SwapChainPass is safe. Secondly, we must do safe to retain colors outside our current gamut. Look at this photo. This is sRGB output. So we're working in BT709, but note the crazy wide color gamut. Colors beyond 709 are negative. But like Heaven is so old now, its pipeline is 709. So where is this wide color gamut coming from? We'll get the color grading stuff to work, maybe add in a gamut expansion. That's why it gotta be safe. Let's make it into a common function, and don't forget the other variant too. Now you go back, it should scale, both of it. If you've seen Ritsu's video, ToneMapPass is used to aggregate every effect. I'll set it up for Heaven, but then also explain how naively using it does not give the best result. First, save the original linear Untonemapped color, then gamma encode as normal for LUT. Now re-enable LUT to sample the gamma 2.2 color. Finally, it's time for the ToneMapPass. Like the other function in draw, we need to give it linear color. So decode gamma right here. And you don't need safe yet. That means we can just remove the decode down here since it's already linear color. Alright, back in. Let's turn off gamma correction to not have it mismatch SDR. And then load the new shader. The LUT graded color is now HDR. As advertised, the color is tone mapped. All color grading sliders should work, and wide color gamut should be safely handled. Alright, ToneMapPass is kinda cool. Seems like we're chilling now, right? Well, this is ToneMapPass, and this is raw HDR. Look at the highlights. It's completely blown out, white, like inverse tone map looking. To show you why this is the case, I'll break up ToneMapPass. We now only give ToneMapPass one parameter since we'll do UpgradeToneMap ourselves. Basically, UpgradeToneMap is taking HDR luminance and slamming it on SDR chrominance and hue. I'm not saying just avoid ToneMapPass, but you can't slap it on and walk away. Now here's the info dump on ToneMapPass. We'd even use apply per channel correction. It can restore blown out colors, but in our case, we can stop the blowout before it happens. Perhaps you read the last slide and got confused about the per channel, max channel, luminance. Well, here it is. Per channel scaling or blowout. You can see that when we crush down the channels, it will hue shift and then become white. Meanwhile, max channel doesn't blow out. It will just scale down until the max channel meets the threshold. Luminance is just like max channel, but luminance becomes the pivot in the scaling. Note how it can overshoot. Now, with the scaling, especially max channel scaling, we can scale the color down before the LUT so it doesn't get clipped and sample it with maximum chrominance. Here's Resolve, LUT, and Gamma, lots of changes. First, we need color neutral before the LUT so that we can do the max channel scaling. Starting here, of course we get the max channel. Look how easy you can swap it for Luminance. Then apply Reinhardt on the value. Reinhardt's probably the simplest roll-off. This is a rational function. You can control where the asymptote lands and it will just roll off. That simple function is right here, but I commented out because I found that I need to overshoot the peak to actually push up to 1. That's why there's extended right here, which you can specify white clip, kind of like the maximum input expected value. We even have it piecewise, which you can specify a threshold before the roll-off actually starts happening. Probably overkill to be honest. This then applies to scaling. And so we can use color neutral to sample the LUT. We have this debug compare, so let's actually look at it. Dang, look at that. 0 blowout on the sun. You can also see how LUT increases contrast and saturation. Then run that UpgradeToneMap. You can also specify the strength by the slider. ToneMapPass can be customized a bit more. Since the raw HDR color only reaches like 4000 nits, I'm gonna switch to a more aggressive tone mapping. Compared to Reinhardt, Hermite Spline is more natural and aggressive. I really like the white clip scaling, and you can make it fit the available luminance even better. And here's the result. Firstly, note that hue correction is turned off. If it's on, ToneMapPass will run an SDR per channel tone mapper to superimpose its hue on our color. Secondly, we need some blowout. Since the color grade from the LUT is pretty light, you can turn on per channel to emulate the original blowout, or you can mess with the saturation sliders. But this is a luxury. Other games has heavy-handed color grading, and bright stuff like fire texture having inverse per channel blowout built in. This forces blowout to be before color grading, else the hues are gone. Now back to our LUT and Gamma function. Doing this will net us both per channel hues and blowout. First, we run a near SDR per channel tone mapper. Values are arbitrary too. Anything's better than just clipping. Then we superimpose the color on, and I'll finally explain what I mean by that. We encode our RGB colors into uniform or perceptual color spaces. There's quite a few of them, but we're using OK Lab here. It separates our color out into a lightness component and then a 2D vector for our hues. So it means that we can blend the color without touching the luminance. The length of the vector is the chrominance or saturation. We can interpolate the 2D vector to change hue, and we can scale it to change saturation. Don't worry, you can be lazy, as the RenderDX has functions for this too. And since we're doing this ourselves, we can turn it off in ToneMapPass. On the right is with the stuff on, it's now blowing out yellow, the golden tint. Here's another example. And of course, the sun. This is the boring part.
Oh my god.
Rename the mod, make new values in the constant buffer, make sliders for the values, and use the values. When the swap chain is created, you can get the user's peak for them. So you can make this function right here, then you need to scroll down and register it. Finally, our LUT resolve had too strong of gamma. You can take a non-gamma corrected screenshot and compare it with SDR. Don't be like me and do this sooner. Without changing deeper RENODX stuff, you can gamma correct upwards before ToneMapPass. Well, you made it to the end of the video. If you followed along yourself, hopefully you learned something new about HDR. And if not already, you should join the HDR Den and RenderDX Discord. That's where I learned all this stuff from. Anyways, here's more shot of the benchmark.